I welcome all to this video lecture. In this video lecture, we are going to discuss about race-free state assignment. Let us consider this example for a race-free state assignment. It is an 4-row flow table example that we are going to see now. First, we have to put the transient diagram for this flow table. Now let us put the transient table, and this circled one where this table state where that has been got circled. Now let us put the transient diagram. Now let us have a 4 state, that is A, B, C and then D. We have a 4 state. Now let us mark the transient. Let us consider first as A. From A to B and transient state, A to B and then A to D. Both were the transient state from A to B and A to D, and then B to D and then B to A. And then next we have to take an C, that is C to A, that is C to A. Here C to A and then C to B, here C to B, and then from D it goes to C. Both here we can have D goes to C. From this flow table we have marked the transient diagram. In this transient diagram we have an race condition. Now let us check the race condition for this transient diagram. Now the transient from A to B we have 1 bit change only. From A to B we have an 1 bit change only. From B to D we have 1 bit change. But here we have a 2 bit transition from B to D. Here we have a 2 bit transition from B to D, and then C to A also we have a 2 bit transition. So we find and race between B to D. We have a race from B to D and then from C to A. With this we have find and race. Now we have to eliminate the race. Now to eliminate the race we have to assign a 3 variable binary assignment. With the help of this flow table we are going to assign a binary assignment. Here this is a binary assignment with respect to the flow table have been taken. Here the A has a value of 0 0 0 0 and B has a value of 0 0 1 and then C has a value of 0 1 1 and then D has a value of 1 0 1. The transient from A to B we have a 1 bit change, so we don't have any problem in it. Then the transient from A to D, here we find a transient from A to B it has a 1 bit change, so we don't have any problem in it. Now the transient between A to D it has a 2 bit change, so here we have we need to assign an intermediate unstable state variable. The intermediate unstable variable of A and D is E. The A goes from E to D. As such, from D to C, the intermediate variable is G. Now let us see the transient from C to A. Here my transient goes from C to A through F. The F is nothing but the intermediate state, that is known as F. It has a value of 0 1 1. Now with the help of this binary assignment we are going to construct a new transient diagram. Now our new transient diagram has 4 variables, that is A, B, C and then D. Okay, now let us consider. Now first we have to see from the binary assignment. A. This A goes to B. As such, A goes to B, and then next goes to next A to goes to D with an intermediate variable of E, so that A to E and then E to D. Then A transient is get over. Next is from B. B has to go from D. B has to goes to D, that is a single bit transient. And then next is B to A, that is also a single bit transient. Next we will be seeing C. C has to go from C to B. C to B, that is a single bit, so we don't want to worry that there is no any problem in it. Next C has to go from C to A. If we need to transition from C to A, an intermediate has to be formed, so we have formed an intermediate state called as F. To F, C get transient to A, and then C has to get transient to D, so we need to get an intermediate state called as G. With the help of a G state, we will be transient from D to G and then to C. This is a new transient diagram that we have been obtained from the binary assignment. With the help of this new transient diagram, we have formed a modified flow table, and here we have a new transient. This is a new transient diagram. This is our old flow table, and with the help of this we are going to form a new, what is that, new modified flow table. Here in this modified flow table, the transient, here we have to see that the stable state for A is a stable state, and here A is a stable state. A directly goes to B. Here transient A to B is nothing but a single bit. A is stable, and then A to B, then we have an intermediate state known as that is E. So it goes from A to E and then to D. Okay, then goes to D. Next is B. B is a stable state. This B is a stable state. Next is B to D. It is a single bit transient state, and then goes to a stable state, that is B is a stable, and then B goes to A, that is a single bit transient state. That is not been a problem with the 2 bits. And then next is C. We go for a C. C is a stable state, and then C to A. From C to A, it must goes to an intermediate state. It should goes to an intermediate state, that is intermediate state is known as an F. This F, first the C has to go to F and then to A. This is known as an intermediate state, which represent from the new flow table. Next is D. We goes to D. First we have to see that D should go to C. D should, here we have a D should go to C with an intermediate state, with this intermediate state of G. This is the intermediate state, and then it goes to C state. Okay, and then as such again it has to goes from G to C. Here the transient from D to C with an intermediate state, and then D is a stable state, and then next also gets unstable state, then D to C with an same intermediate state as G, and then it goes to C. Here this is an this table is an new modified flow table. This is a new modified flow table that has been formed from the transient diagram, and then this methodology is known as an shared row method for the race free assignment. In this video we have seen an brief detail about a shared row method for race free assignment. With this I conclude my video lecture. Thank you.